What is going on, ladies and gentlemen? It's Jake, aka StarCoding, coming at you with another video where we're talking about computer science. And today we're talking about complexity. I think I might make it like a series called Just Another Video. So we're doing just another video about the topic of complexity. Just talking about software philosophy, talking about what it means to make good software, and where to begin with that than just ranting about complexity. I have a couple topics I want to talk about, a couple symptoms that showcase in complex systems and how we can identify a system design that may be complex versus non-complex. And so the first thing that really we're talking about, like, why is complexity a big deal? Why do we care about complexity? Well, if a system is complex, then every single time you make a change to that system, you're adding risk of breaking the system and introducing an unexpected change. And so really, when you have an obvious system, something that's obviously made, something that just you read it, it is an intuitive sense to the developer, a person at hand, they can confidently make a simple change and expect that result to make sense. When you make a simple change in a complex system, it's not going to go so well for you. Now, there is, let me see if I can, hold on, we're going to pull out a whiteboard on y'all real quick here. All right. Now, there was this fun algorithm found in a textbook one time talking about complexity and how to put it in mathematical forms. Because, you know, it's science, guys. Computer science, it's engineering. We got to have math, all right? And so what we're going to do is we're going to have a summation of all the parts in our system. Summation of parts. And so for each part, we are going to sum the, oh my good gosh, let's go. Complexity of that part multiplied, dude, please. Oh yeah, that's a nice C right there. Complexity times the time spent in that part. So you can imagine a part in red here, and each part has a complexity associated with it. So like C of P, and it would be like T of P. All right, we're doing math. Big math. Big math. Love it. So complexity times the time, which means that if I have a super complex system, but I only have to look at it once a year, maybe I'm okay. And it's going to be okay. So if I have like 10 parts of my system and one is super complicated, but I only look at it once every rotation around the sun, I'm probably pretty good. But if I have to look at that complex part of code multiple times, maybe once a week, guys, we're approaching chronically complex. It's not where anyone wants to be. Doesn't sound fun, and I promise you it is not fun. So, chronic complexity, we don't want to be there. And does that make sense? Comments, put a comment below if that makes sense. I hope like you can see that in this sign. I know it could be scary if you're not used to seeing a summation sign, but that just means like for each. This is literally just for each part, adding these things together. So it's pretty fun stuff. And there's like three symptoms of what makes a complex system, and one is annoying. I would say it's actually like truly bad. I mean, it's bad. Okay, I will say it's bad. If you are a single developer, it's not bad, but if you have a team, it's bad. And that is change amplification, which just means that, hey, if I make a change in one part of the code, if I make a change over here, I might have to make changes over here and here as well. It's not all in one place. And everyone that's watching this video right now is like, okay, Jake, well, yeah, we fixed that with global variables. Fair enough. Nice. However, when you're making a system that has, you know, multiple different languages, maybe it gets a little harder when the processes change, and it's like, how do I have multiple processes? How I'm going to talk and have the same variables, you know, sometimes you have to make multiple variables that have the same value. It's okay, and just making sure that you can like kind of handle that complexity. It's not too much of a mental complexity, more of just an annoying one. Always use grep. Use some good like code editor tools that can really help you out in that regard. And complex, so cognitive load, the second one. I know everyone's looking at this and is like, oh yeah, oh, I know what cognitive load is. It's learning how Rust works. No, but cognitive load is pretty much how much do I have to know about the module before I can make a change to it. You know, if I have one file and one class, but he depends on, you know, 3 other classes, I probably have to have some sort of knowledge, or maybe these 3 classes depend on our first one guy up here. So like cognitive load is when I make a change, how's that going to affect the system? What things am I dependent on? And kind of just like you have to mentally load all these different classes, interfaces, and modules in your head before you can make a confident change. And, you know, at any part of the code, you're probably going to have to like kind of, there's always going to be some sort of cognitive load with it. That's why it's a engineering job. Pays pretty well. And you can think that when I'm making that model view controller abstraction in GUI interfaces, it kind of reduces that cognitive load where it's a tool to help reduce cognitive load. I can have my model, which is all my actual application objects. I can have my controller, which is where all the interactions are being processed. And I can have my view, which is where all my buttons are, which I probably, going back in time, should have done that the other way around. But having the model, which all your buttons, when you click a button, it goes to a controller that then, you know, puts that controller and manipulates the actual objects itself. And in having some sort of interface abstraction is what can help reduce cognitive load. You can imagine if there was no interfacing at all, it was all just in one big, you know, big mosh, whatever you want to call it. It would be pretty mentally challenging. And this third one is, let's erase that. Unknown unknowns. Oh yeah. If you watch any other YouTubers, they might have mentioned unknown unknowns before. I've heard this term tossed around a couple times. And for me, what this really is industry knowledge with your current niche stack and other things as well. But you can imagine if I'm making an application for Android or iOS, there are some things that I will not know exist until I actually read the documentation and study, hey, this is how I make an application on an Android or iOS machine. At the end of the day, code is code, and you can usually hop into a project and start coding willy-nilly. They usually make it like a hello world program. You can just like start going about your business, doing things, but you might be going about it the wrong way until you actually read the documentation about how that thing works. Especially with like, I mean, that's why web applications are a little bit more simple than building an iOS app. And a kernel module is probably more complicated than a iOS app because of all the different subsystems that are working together. And that's also, I guess, a good way to think of it. It's not dependency versus dependency necessarily, because you can like look in the code and kind of figure out, okay, this class is depending on this class. It's when I have like multiple systems that are all in our, you know, like here we have like, we'll have the app. Hold up, we'll zoom out here in a sec. Ooh. Ooh. When I have a single app that is being accessed by multiple different subsystems, and that could be the hardware, like the operating system I'm running on. It could be like just different processes in general that are all manipulating and touching my app. There's unknown unknowns involved if you don't understand what each of these systems are doing and modifying. And these are obviously the most scary because you just don't even know. You think you're in the clear. You think you're in the clear until you push that production change, and then 2 weeks in the future, you get a phone call at 1 in the morning, and a customer is very unhappy with you. And so they're clearly the most detrimental. And the way that you fix an unknown is by making an obviously designed system, guys, and documenting when things are happening. So those are like symptoms of it. Okay, I think we can all agree that those are some scary symptoms, and there might be more. Feel free in the comments below if you think that this is what I define as a complex system, and I'd be like, all right, that's cool. Let's see, is there a way to kind of like pull out an eraser? Hello, please. Nice. Ooh, get rid of that stuff. All right, so we have our symptoms here. And what causes these symptoms, really? Like when we get down to the nitty gritty, what makes it to where every time I make a change, I'm starting to scratch my head and pray. I'm just starting to pray at this point, dude. Every time I make a change to the system. Two things: dependencies and obscurity. Dependencies. I'm not talking about third-party dependencies, which, by the way, are scary. Okay, every time you add a little third-party module, little npm package, a little bit of a, what is it? What do they call it on C++? I don't even know what the freight package. Every single time you add a package on C++, crazy stuff can happen. But really what we're talking about dependencies are the individual classes and the function signatures. And just, you want to make a change, but everything is like walled off behind functions and like you want to get to the nitty gritty of what's happening, but there's so many different layers of abstraction. You're getting so deep into the process. That type of dependency, when there is an issue deep into the dependency tree, that can be a challenge. And it's not like that we should not have dependencies. Okay, if anything, computer science is the art of managing dependencies and making sure our dependencies make sense. And so if you can structure dependencies in a way that are obvious, when something goes wrong, a developer will be like, oh, I know what's going wrong here. And they can jump to that part of the dependency tree. And because everything is so nicely separated in concerns, they know that I can just make my change here and it's going to be okay. And things are going to just get back to working. When it's not fun is when there's just like a bunch of helper functions that are doing helper function things going into nested helper functions, and you start to like lose track of, like, you might have started, let's see if we can map this out. You might have started here, and then it like calls into a module that's doing code here, and then it goes like into a module here, and maybe at some point like a wait or like a lock is called, and you have to like kind of remember like where you are overall as you go down this dependency hierarchy, and it can get crazy. Okay, the rabbit hole can get crazy, but if you have like clear checkpoints of like where you stop, that might help reduce complexity. So I'm not saying like you obviously have to go deep down when you're doing these crazy dependency chains, but if you can like make it to where I can read this makes sense, and then when I get to this blue part, there is a logical checkpoint, a logical mental checkpoint I can place and be like, okay, whatever happened here does not matter anymore. We are all good. It's like playing Dark Souls or Fly Night for anyone that's based. Okay, and obscurity. Obscurity occurs when important information is not obvious. And for everyone that's saying, okay, important information not obvious, well, we just gotta document it. We just gotta put it in a, Google Doc file, maybe in a .md file, maybe put it in a README file, throw it off somewhere for people to read. I mean, it's hard to teach a team through documentation. documentation is like the last resort that should be used when it comes to informing people on how the system works. And if anything, the need for extensive documentation is often a red flag that design isn't quite right. The design should just chef's kiss make sense on its own. And so yeah, it's kind of what we're talking about when it comes to complexity. We're talking about making systems that are obvious in design, hopefully. And again, the importance of this is just because if we can eliminate the complexity, then every change we make should feel simple, and we don't introduce risk, unnecessary risk, because of complexity. And a lot of times it is incremental. It happens over time. It's not like you make one catastrophic change and all of a sudden your system's complex. If anything, it's a symptom of being, I guess, pressured to write tactical code, which is code that runs, but not thinking about how it works in the longevity of your software, which will probably be in a different video. But guys, this was just a quick rant. It was a quick rant on complexity. Hope made sense. Hope it was entertaining. If not, well, we tried. It is just another video on complexity after all. So there's other topics that are exciting out there. But yeah, that's it for me. Cheers, guys. Peace.